Hey, hello everybody. Welcome to another class. So Friday night, nothing better than learn, no? Let me see if everything is working fine here. Give me a second. Hello, testing. Friday night, nothing better than learn, no? Okay, so let's go. In the last class, we learned about abstraction. We had an example, try to lay the foundation to understand how a computer store information or data. And one thing that is very important, like almost everything, we will be learning by going down in levels of abstraction. It's not impossible to learn something new, start all the way from the bottom. We start someone like high level, go down a little bit, then go up, and then take a lot of time to really go all the way down. We can compare this to any other like area. It's kind of like that. So I hope the example was good enough so we could have an idea that with lights we can represent numbers. As more light we do have more numbers, and every time we add a new light we double. Is that why computer memory goes in double? 8, 16, 32, 64. Just a few exceptions to that, because sometimes the bits can be used for something else. Sometimes it's a shared memory, but usually it's like this. Today we're going to learn about some very basic thing, that the idea of bit and byte. And looks silly. We'll do some math, something during the class today, but it's just to, first of all, do some mental exercise. We are not going to be learning like advanced math, anything like that, but just to prepare our mind. It's like when you do some sport, you go to the gym to learn box. You do like rope jumps, you do push-ups, you do sit down. It's not boxing, but it will help you. It's gonna prepare your body, your mind for when you need to do the boxing. So it's kind of what we're doing here. If by any chance you don't like the class today, it's not clear, it's confused, don't worry, don't give up yet, because this is not really coding. It's just to help you understand some little thing that may come along and you can understand better. You have a better understanding. Okay, so let's do this. I try to make as simple as possible, but there is some basic concept that I want you to have exposure. With time and repetition later on, it will be easy and easy to understand. The first definition is bit. So I open here the Wikipedia, but the definition of bit is this: is the most basic unit of information that a computer can use. It's just on and off, voltage or no voltage, magnetic point or not. So something that represents only two stages, on and off, true or false, 0, 1. So with this, it's not possible for us to do anything. Like, how can you make a computer that only have one thing? So the scientists create the idea, okay, let's put bits together. It's kind of what we saw here. We put bits together, like we have 2 bits here, we have 3 bits here, we have 4 bits here. With this bit together, we have like all kind of combination with those bits on and off. And if we like math, this is like 2 power to the number of bits. 2 power 1, we have 2. 2 power 2, we have 4. 2 power 3, we have 8. 2 power 4, we have 16, and so on. So, the byte, if you go to the definition, is a set of bits, usually with 8 bits. There is no clear definition, but it's most common to have 1 byte as 8 bits. For example, if you are doing an exam or a certification, and there is a question like, oh, how many bits form a byte? And the response can be 8, 16, 10. It's a hard question because the most common is 8. But if there is an option, usually 8 Okay. If there is one option, always 8, no, because in some different place can be more. So it's kind of like just to understand. When we talk about a byte, 99% of the case, we are talking about a set of 8 bits. But not necessarily every byte everywhere is only 8. Could be less or more. And there is something interesting here, is because as the memory grows, we have more capacity. So we have more bits, okay, you have more bytes. So when we have 1024 bytes, we call a kilobyte, or just K. If we have 1024 kilobyte, we have 1 megabyte. If you have 1000, sorry, mil is because it's Portuguese. If you have 1024 megabytes, we have 1 gigabyte. It's like a power of 2. And you can ask, why is not 1000? Because K usually is 1000. 1 kilometer is 1000 meters. 1 kilogram is 1000 grams. It's because we are dealing with the binary system. Computer uses like binary system, and that is why we have 2 power 10, that is 1024. Okay, so it's silly, but at least now we can understand what is this 1 kilobyte, 1 megabyte, 1 gigabyte, 1 terabyte. This is the most common. Like, usually computer has memory in gigabytes and hard drive in terabytes. 1, 2, 3, 4 terabytes. 16, 32, 64 gigabytes. Because as we know, I'm not going to down that, but I guess we all have an idea that memory, like RAM, is more expensive than the storage. But I'm not going to go that, but it's just to give an idea. And now at least you can understand those numbers that all power of 2, and they goes by 1024. Okay, something else that is, I took the risk in adding this content. I could easily bypass it and not cause any harm to people that is learning code. But in my career, I feel that helped me to understand something. If someone go to certain areas like networking or need to go to low-level coding, this concept is important. And people learn this at university. So I have a formula to teach this in a very simple way. And that's why I took the risk. No, I put this content here. But if for some reason you don't like this class today, no worries. We don't need this to be a software engineer, to be a coder. This is just an extra that will help us in some situations. Okay? So, the first thing to, and there is one good thing here. It's kind of a mental exercise. Let me do this. Because it will make us, our mind, like do some exercise, understand. So it is not really coding, but it's kind of help in that direction. So first thing is numeric system. The numeric system that we learned it is impregnated in our brain is decimal. The decimal is what we use daily. Every number that humans like deal with, we think as decimal because we use the digits 0 to 9. It's decimal because there are 10. 0 to 9 is 10 because 0 conta as 1 and 9 is the last one. So every number that we use, 24, 51, 1,370,000 and blah, 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 they're all decimal. So our mind already understands those numbers quantitatively. So if you see 1, we can count in our hands. 1, 2, 3, 4, 5. It's very intuitive. However, computers, they cannot understand decimal numbers because 1 bit cannot have 0 to 9. 1 bit is just 0, 1. We can't represent in 1 bit 10 digits. It's just 0 or 1. That's why we had to use a different numeric system to make it easier for us to give data and read data from the computer. So that is why there is some important to understand this, because down all the way level in abstraction, everything that happens in the computer is binary. It's just bit and byte. There is no like 2, 3, 4, 5, 6, 7, 8, 9 digits. All of this has to be converted to a sequence of 0s and 1. So it's nice to understand this binary. So we kind of learn a little bit in last class when I try to explain you all. Do you know? When we have 4 bits, each one of those bits combination can be a number. So I already taught you, I already explain you how to represent numbers with bits. As long as you can set these values zero, you have some electrical component that can store that, like capacitor, transistor, or whatever. In the beginning, like valves, it's like lights, like light bulbs. We can store information. If I have 4 bytes and lights that I can turn on and off, I can represent 16 numbers from 0 to 15. That is the idea. So, in here, let me open this guy so we can try to do this. We are learning about binary system. So, in general, is every number represented by zeros and ones. There is no extra digit. And one example here that we already saw, 1011 is the same as 11. And we can see that is 11 because of this. If we go here, let me open this guy. I should not have closed it. Look, 11 is, this is on, this is 0, 1 and 1. This is 11. And then we're going to understand now how we can easily form those numbers. Is that my goal? And then we can see how can we convert to and from decimal to binary. So I think I have a nice way to teach it. Let's see if it's going to work here. The first thing, and I had to learn this because back in the days you have to do tests. I was teaching and make tests for exam and then doing certification that we should be able to prove that we could do those calculations. So let's do this. I will call this here binary. And we know that binary, we can only have 2 things. And we learned that we can combine bits to make a byte. So let's think like this. This is 1 bit. I put the text here. And now let's put a byte. A byte we already learned is a set of bits. So I put like 1. I put them very close with each other. 2, 3, 4. Now I'll be lazy. I will get this 4. I will copy. Oops, sorry. I will copy all 4 and put here. So now we have a byte. That a byte is usually 8 bits. Let's see if I can make this pretty. How should I do this? This? Okay, cool. So now we have a byte. If I want to use those bytes to represent numbers, it's like decimal numbers. Every one of this position will represent a number for us. So let's try to do this. I will do this. And I start with, just to make it easier for you to memorize, let's start by this. I will put the first one. Then it will be 2, 4, and we're going to double it. 8, 16, 32, 64, 128. So let's see what we can do here to make this pretty. Okay. Putting those numbers in this way, we can easily see, oh, let me, this is kind of not so cool, but just to make this. Let me align everything on top. Boom, okay. So let's do some exercise. Imagine that we want the number 47. We want to represent the number 47 decimal. For us, that is very easy to understand. We say, okay, it's 10 4 times plus 7. I'll get this, guys, and I'll turn everything off. And then I'll make a copy. How do we convert 47 in decimal to binary? Basically, what we need to do is we need to turn on all those bits here that you sum, and the total will be 47. Look how nice this is. If I want to make 47, should I turn the bit 120 or 128 on? No, because if I turn on, I already have 128 that is way more than 47. Should I turn on the bit 64? No, because 64 is even bigger than. Should I turn on the bit 32? Yes. So now, where I am in 32. And then I look the next. Should I turn on the bit 16? Well, let's see, because if I add 16 to 32, where I will be? 8, 4. So I already passed 47. So this bit will be off. So I will remove this. So far, I will have 32. Now, should I turn on the bit 8? So let's see. If I turn the bit 8, let me do this. So I will be at 40. 40 is less than my target? Yes. So what I'll do, I will turn that bit on. So bit 8 will be on. Now I can see, okay, so now should I turn on the bit 4? Well, if I turn on the bit 4, I will be 44. That means, yes, I will turn the bit 4 on. Oops, sorry. Should I turn on the bit 2? Well, if I turn the bit 2, I go to 46. That means I am going to turn it on. And now it's easy. Should I turn on the bit 1? Yes. So, if I think in terms of numbers, this will be 0, 0, 1, 0, 1, 1, 1, 1, and 1. The 1 will indicate all the numbers that the bits that are on. So it'll be like this: 0, 0, 1, 0, 1, 1, 1, 1. Somewhere in your life, you see a number in bit binary and you have no idea, whoa, what the heck is that? How can I translate this? So now you have an idea how to easily convert from decimal to binary. Let's do something else. Let's do another exercise. I move this. Let's pick up another number. Let's play here 137. Of course, what is the maximum number we can represent with 8 bits? That is a good question that I already saw in exam, certification. If you use the math, if you turn everything on, will be 255. So it's 0 to 255. So we can represent 256 numbers. We may do that exercise so you can understand. So let's see like this. How can we represent the 137 in binary? I say, okay, if it's binary, I need bits. So let's put the bits here. And let's try this. We always start with the highest value, because if we start from this, we're going to turn on a lot of bits that later on we cannot combine. So we start to say, okay, from the left, you say, do I need to turn on 128? Yes, because look, 128 is less than 137. So I will get this bit here and I will turn it on. So now, just to help us with the math, where I am, 128. Oh, come on. 128. Next question. Should I turn on the number 64? The bit represent the number 64? No. Otherwise, I go to 180. I pass it a lot. So this guy will be off. Should I turn on the number 32? No as well, because if I turn 32, I go to 160. So this one will be off. Should I turn on the bit 16? I can maybe do this easier, no? 127 to 137, I need 9. So I can speed up this. So I'm not going to turn this on. So I can even put the numbers here already. No? Will be, oh, sorry. Come on. Oh, I don't need this, is this. This will be 1. This will be 0. This will be 0. 16 it will be 0 as well, because if I put 16 here, I go way above. If I put 8, well, 8 is a good candidate, because look, if I put 8, I go to 6, 1, so this is 3, 136. So I said, well, now I just need 1 extra. So here will be 1. Now easily I can go 0, 0. Oops, come on. 0 and 1. If I want to match the color, so everything that is 1 will be yellow to represent that the bit is on. And this is how we represent 127 in binary. 1, 0, 0, 0, 1, 0, 0, 1. That's kind of interesting, right? When we can convert from one type of numeric system to another one. So as you can see, it's not hard to get a decimal number and find the binary representation of that number. And the inverse is the same. For example, let's now get a number in binary. Let's get this number here. 1, 0, 1, 0, 0, 0, 1. How many have? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this number in decimal, how much? Oh, in binary, how much is in decimal? Well, I will do the inverse. I will copy this. And now it's even easier, because what I'm going to do, I will put those guys here. Will be 1, 0, 1, 0, 0, 0, 1, and 1. Oops. And if I want to make my life easier, I will make those guys yellow, so I know that they are on. And I know which numbers I will use. So let me move this a little bit here to make my life easier. Here's fine. So I can start from wherever I want now. So The bit 128 is on. Oops. The bit 64 is off, so I'm not going to add. The bit 32 is on. The bit, 32, the bit 1684, oh, wait, something is wrong here. Let me do this, make my life easier so I don't do silly mistakes. I'll get this guy, oops, yeah. Move up here. And this one I perfectly align so I can see. So 32, 128 is on, 32 is on, 1684 are off, and then we have 2 and 1. So if I want to discover, it will be 13 plus 1, 6, 163. So now you learn a trick. There are some other ways that you're going to divide by 2 and all that. So that is kind of like a little bit like annoying, but this is the easiest way. I remember during my test, I will create this table here by double it, and then every number you just put there and then do the math to see which number represents. So this guy is equal to unless we did some bad math here, this is correct. So you can do some exercise, and now you can use AI to, this in binary. It's going to answer you like very quick. Even now, I guess, if you go to Google, you can do something like this. Google, how much is the binary number 1101111 in decimal? And AI is going to be able to give you this. See how they are doing this? It's similar to what I taught you, and then you can do the test. Back in the days, and even today, depends of kind of exam or certification you are doing. You may be asked to do this, but it's nothing really needed to learn code. But it's a good knowledge to have. The same idea we'll learn about 2 other but common numeric systems, octal and hexadecimal. Octal is because we only use 8 digits, 0 to 7. Hexadecimal is integers because we use 16 digits, 0 to 9, A to F. This is kind of common because we can compress information, and I'm going to keep this example there so you can see it. So in octal, we use the digits from 0 to 7. Binary is only 0 and 1. Decimal, 0 to 9. So this you can see, it's silly, it's almost this, but for some case, is easier to, people use it in got convention, so it's nice to understand. And this one here, you see that is very interesting because now we can represent bigger number with less digits. Let's go there to try to understand this. So this was binary. I'll keep the text there. So let's put octal. So octal, we represent numbers. Let me type here. With, for example, octal does not has this number because 89 is not an octal number. Octal digit. So we could have something like this. The 7, we could have like 3, we could have 0, we could have 1, we could have like 4, 5, 7, 1, 2. But that is interesting. This here is, if it's in octal, that we represent like this way, is not 45,720, 12. because this now is using a different numeric system that represents a different number. So I teach you a little trick now how to convert from octal to binary and from binary to octal. The first thing to make us understand is to represent the full set of octal 0, 1, 2, 3, 4, 5, 6, 7. How many bits do you need? I need to have numbers from 0 to 8. If we look here, 0 to 8, we only need 3 bits. If I turn it, not 0 to 8, 0 to 7, sorry. If we go to this example, let's go back here just to show you this. Is that why I use this? With 3 bits, we have to 0 to 7. And now we use 3 bits for every one of the octal digits. And then we can easily compose and decompose octal to binary, binary to octal. And of course, later on, if you want, you can convert to decimal. From binary, you can easily go to all the other ones, as long as you know this trick. What is the trick here? Let's get the number, let's go back here, the number in octal. Let's put 1, 2, 3. What is this? So what we need to understand is we'll need 3. Let me get this. Oh, sorry. We'll need 3 bits for each digit. So it'll be this for 1, this for 2, and this one for 3. And use the same logic. So who is 1? Is just this first one. Is 1, 2, 4. So we make this off, off, and this one on. So it'll be 0, 0, and 1. Because if we turn on all the bits here, the number that we'll have is 1. This guy, represent the first digit, 1. Now let's go to this 2. 2 I know very easily, né? Will be, if I go here, it will be 0, 1, and 0. Because I just need to look. Oh, it's only the bit that represents the value 2 that will be on. If I want to represent this, it will be like this. And now it's 3. 3, if I look, well, will be the bit 2 plus 1. So it will be the last 2. So it will be like 0, 1, and 1. If I want to represent by color, it will be like this. So this guy will be in binary 0, 0, 1, 0, 1, 0, 0, 1, 1. If you want to know in decimal, it's just to apply the same rule. Will be like 1, let's do it real quick here. It will be 1 plus 2. So we skip 4 and 8, and then plus 16. And then we skip 32, and you turn on 64, something like this. Now I can sum this 10, 13, 7, 8, 83. Unless I did some wrong math there, that would be the idea. You don't need to like this to do coding. This is just an extra. Let's do another example here of octal, so then we can move to hexadecimal. Let's put the number here 7165. Please remember, this is not 7,165. Well, maybe it is, but in octal. It's not the same number for us in decimal. It's a different representation of the same amount. It's like miles and kilometers. We can have the same distance, but will be different values because they have a conversion. It's very similar here. So how we do this? Well, we use 3 bits for each digit. I will make our life easier. I will do this now to make our life easier. It will be 4, 2, and 1. So we can easily see 7 will be all 3. 7. I will make them all true. So it will be 1, 1, 1. I will copy the same guys here. Oh, sorry. Now we go to 1, and now we kind of like, we already have some, oops, sorry. We already have some muscle memory. Because 1 is just the last bit. Now 6. Oh, let me just make this. This is 1. 6. We already have some muscle memory as well, no? 6 will be 4 and 2. So this will be 6. And then 5. We already can easily see as well. 5 will be 4 and 1. So the middle will be 0. If I want to match the colors to be like everything nice, this will be on. This will be on. Those 2 will be on. And those 2 will be on. And this last one is that, oh, sorry, this one will be 5. So in binary, oh, sorry, let me put this way. In binary, oh, 7165, oh, 7165 is equals to, in binary, 111 001 110 101. How much is this in decimal? It's just to apply this logic. Pay attention that we have more than, let's do this here. We have more than 8 bits now here. So we're gonna need more than 1 byte to represent this number. So let's do this. If I keep following this, it will be 265, 512, and let's, and then 1024. Let's see if we're gonna need more than this. Probably no, and then I can reduce the space here a lot. So, actually, let's see. I guess I did something silly here, but let's see how I'm gonna fix this. So this go here. Come on, I'm gonna waste some time here. Let me do this. I will do. Oops, look what I do. It's silly, but it's gonna work. Because this helped me visualize all the bits that I need to turn on, and I know which values I need to add. Good night. Let me move this a little bit here. Let's see if we can, if we don't make a mess. So one, oops, sorry. I go wide here. I will make a lot of space. So then I have no excuse to align those guys. Will be here, 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 here. And then I need 3 more. So what I need you to realize, this number in octal, we only use 4 digits. Look how many digits we use in decimal. Oh, in binary, 10. Now let's see how many we're gonna use in decimal. So as we can see here, it'll be like, this is gonna be on. This is gonna be on. Then we have, this is off. We have the next 2 on. Oops, the next 2 on. Next 3 actually. Then we have 2 off. Oh wait, something is wrong here. Let me start from this. On, off, on, off, on, off, off, and then 3 on. We need 1 extra bit. Is that right? Yeah, it's right. I put a big number. Will be 2048. I should have skipped this example, but that's good. We do some more exercise. So now I have the last 3 on. So how we do this? I will make my life easier. I will open a calculator. And then I say, okay, 2048 plus 1024 plus 512 plus 64 plus 32 plus 16 plus 4 plus 1. And look, this number in octal, in decimal is, oh wait, what is showing there? What happened here? Oh, I did something, oh, this. I pressed some button that changed it, so will be this. This is in decimal, this is in binary. So what can we learn from this? That as more digits we have, less, as more digits we have, less space or less digits in total we will need. For example, this number in binary, we need a lot of bits because we have only 2. In octal, we have 4, in decimal as well, but pretty is a smaller number. Okay? And then you can ask me, oh, why I needed this to learn code? You don't. It's just to understand how everything is an illusion. Even the numbers that a computer uses is not the one that we use. Behind the scenes, everything has to go to binary because it's how it can be executed in the electrical world, like with wires and transistors and circuits. Okay, so this helps us to open our mind, and we understand that almost everything there is a level of abstraction. Because even here, I'm showing yellow or white for on and off, 1 and 0 for on and off, but in reality, there is no 1 and 0. Will be voltage intervals. Will be some electronic components holding charge or not. Okay, now let's go And I promise, this is the only class that you're gonna have that is kind of always pure math. But no, this is interesting. I want you to even open your mind to understand, oh, there are different numeric systems that we don't use because for us make no sense. The binary is the must because a computer can only do anything in binary. So hexadecimal is interesting because hexadecimal come from 16 and use like the decimal digit. So is the digits from 0 to 9 in A to F. And this is very nice because I saw some students go, well, how come I'm gonna add letter with numbers? 3 plus B, what is that? Because in this case, B represents a number. Look how interesting this is. Cool, let's go back there. I'll do this, I'll move this guy out of here. And what should I do here? Yeah, let's go to hexadecimal here. Hexadecimal. So hexadecimal is interesting because look, we use all the decimal digits plus the letters from A, B, C, D, E, and F. So look what we have here. We have, oops, sorry. We have this. The digits, numeric digits are normal, but the 10 will be A, 11 will be B, 12 will be C, and so on, until here. So now it's awesome because with just one digit, not one bit, one digit, we can represent up to 16 different values. So then let's do some exercise. How can we convert from hexa to binary, for example? Let's do this. One possible number in hexadecimal would be something like this: A1C. A1C. Okay. How can we convert this to binary? It's the same idea, but now there is one catch. If I need to represent 16 different values, how many bytes, how many bits do I need? We already saw the other class, we need 4. If I turn everything on, it will be 15. Everything is off, is 0, and there is all the middle combination. So we'll do the same idea. We'll get like those 4. For each one of those digits. Let me be smarter here. So it'll be something like this. And I will copy this guy. I will put here and see if they're gonna be aligned. Ah, come on, I didn't want to miss out. So this will make it easier for us. Oops, sorry. So this will be A. Oops, sorry. This will be A. This one here will be 1, and this one will be C. And then we have to realize, okay, A is 10. 10, what I do, I will turn on 8, and I will turn on 2. That will make 10. 1, we know, 1 will be just 1. C is 12, so 12 will be 8 and 4, 12. So if I want to put the numbers here to see the bits, will be 1, 0, Good night. 1, 0, 0, 0, 0, 1, 1, 1, 0. Oops, sorry. 0 and 0. Oh, one thing that I didn't show, how to convert from binary to octal. The same we're gonna do for decimal. So let me show, hexadecimal. Let me show for hexadecimal first. So it's the same idea in reverse. For example, if we get the binary number, let's put here binary number 1, 0, 1, 0, 1, 1, 0, 1, 0, 1. We'll do the same. We will break this down in 4 and 4 bit. Let me copy this. We get 4, 4, and this will be 4 as well. And then let's look, okay, if I have this and this on, this will be how much? It will be this and this on is 5. If I have the first one, 8 plus 10 is 11. 11 is B. This is not 10. This is 1, 0. That in binary is 3. So 3 will be 3. Oh, but beleza. Oh, okay, good. Just to let you know, I do have another channel that I speak in Portuguese. So if you want to, this will be a newer content, but so this is how you convert from binary to hexadecimal. It's the same idea to octal. However, in octal, we're gonna group by 3 and 3 bits. Okay, so I know it's not a very easy thing, but it's just an exercise for our brain to start to create more connection. Remember, the brain is like a muscle. As more as you train, better it's gonna get it. We don't rest our muscle to get it better. We have to exercise. So that is the idea. All the class today was just to show you, well, there is this idea of a different system. The most common one, there is even more that been used. We can create any system. So the most common one is those 4. Binary, because it's how any computer in the world can operate, unless there is a quantum computer, there is some different there. Octal and hexadecimal. The advantage of hexadecimal is that we can represent bigger numbers with less digits, because now it's instead of 0 to 9, we have 0 to F. So every like if you convert this to decimal, do the exercise. You see that there's a big number here. We may use more than 3 digits to represent this. If I put like F, 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 will be everything 1. Cool. Let me see what else I had for the class today. Yeah, I think we are good for today. Was more like a warm-up. Don't get scared, and please don't drop out just because of this class. I knew the risk to bring this topic because university teachers, we have to learn there, we have to do exam, and then I want you to have the same experience. If you didn't understand, maybe watch the class again, maybe go read some to see if you can do some exercise by hand, but it's not required. If we get 7 out of 10 engineers today, and you ask them, oh, please don't refresh your mind. Show me how to translate from octal to decimal. Probably say, wow, I did this at university, I don't remember. But now I don't need it because I can use a computer to do it for me. But it's just to show some difference that we have to do to adapt our mind, our knowledge with the computer world. Because one of the big things we need to learn is to use abstraction so we can adapt our mind in a way that we can talk with something that is a machine. Coding is basically that. Cool. Well, I hope you enjoy. Don't get scared. And God bless you. Have a nice weekend. See you.